today we're going to be going over the test review for the Unit 6 test over polar coordinates, okay? So here we go, number one. So first off, let's change this to degrees. So this point is negative 160. So again, remember how we do that? We go to our 60-degree spoke here, 30, 45, 60. Normally we would just go up 1, but since r is negative, we go to the opposite side. And there you go. So there's that point. That's negative 160. Now we want to find 3 other representations. So remember, my points are going to be something like this. It's going to be a negative r, positive r, positive r. Okay? So for this first point here, since the r's are staying the same, their angles are going to be coterminal. I'm going to subtract 360. Okay, and so 60 minus 360, that's going to give me a negative 300. Okay? Now, because I'm changing signs here, because I'm changing signs of the r, the original angle that was given to us and the angle of this point right here is 180 degrees apart. So we can either add 180 or we can subtract 180. It doesn't really matter. In this case, I'll just subtract 180. Okay, and so 60 minus 180 is going to give you a negative 120 degrees. Okay. Last but not least, for this point, because the r's stay the same, we now take this angle here, and we're just going to go ahead and add 360 to it. And so when you do negative 120 plus 360, why are we adding 360? Because the r's stay the same. That means this angle and this angle are coterminal, and so that gives you 240. And there you go. There's your multiple representations. Okay, negative 4, negative 330. Okay, negative, so negative negative angle means clockwise, so we're going this direction now. So that's a negative 90, negative 180, negative 270, 300, 315, 330. Okay. Now, normally, even if it was just a positive r, we would go up 1, 2, 3, 4, okay, and plot a point there. But since it is a negative r, we're going the opposite direction. And so that should be plotted right here, and this right here would be your negative 4, negative 330. So again, multiple representations really quick. We know that we're going to have another negative r, and then we're going to have 2 positive r's. So we go back to our original angle and we say, okay, hey, since the r is the same, they're not changing signs-wise, the angles are coterminal. So I would go ahead and I would take that negative 330 and add 360 to it, and that would give me 30 degrees. Okay. Now we're changing the sign with r, so that means from our original angle to this new point here, they are only 180 degrees apart. So in this case here, I don't have an option of subtracting 180 because that would make my angle less than negative 360, so I have to go ahead here and add 180. So negative 330 plus 180 is going to be a negative 150. So last but not least here, since the r's stay the same, we know that this angle and this angle have to be coterminal, so I'm going to go ahead and I'm going to add 360 there, okay, because I need a positive theta, and again, I can't subtract 360, because if I did, it would make it less than negative 360. So negative 150 plus 360 gives you a positive 210. And there you go. There's your multiple representations. Okay? All right, so we want to find the distance. That comes from a formula. Okay, what I would do is I'd ideally put everything in the terms of degrees. Okay? So let's go ahead and let's find the distance then. So the distance is equal to the square root of r1 squared. So again, if you want to label these, let's do this. Let's do r1, theta 1, r2, theta 2. So it's going to be r1 squared plus r2 squared. Again, make sure you put a parentheses around it if you're going to leave a negative there. Okay. Minus 2 times r1 times r2 times cosine, okay, of theta 2 minus theta 1. So negative 105 minus theta 1, which is 170. Now we're going to go ahead, we're going to type that into our calculator as we see that. So the square root of negative 4 squared plus 6 squared minus 2 parentheses negative 4 6 cosine of a negative 105 minus 170 close parentheses, hit enter. Yep, and so if you did that correctly, round to the tenths, we got 7.5 units. I just read a U for units. It didn't give us. If I give you a unit on the test, obviously. Okay? All right, next one here. Let's go ahead and let's change them to degrees real quick. First, that's the negative 30 degrees. And then that is going to be 135. It's just easier to do that. So again, here we go. Square root. Negative 1 squared plus a negative 5 squared minus 2 times the negative 1 times the negative 5. Again, guys, we should know by now. I mean, I labeled them for you in the first one here, but you should know what R1, R2 is, what theta 1, theta 2 is. I know I'm speaking through this again, guys. This is all review, okay? So I'm not going to spend a detailed time explaining it all, just real quick getting through it. So cosine of 135 minus a negative 30. And let's go ahead. Okay, I showed you how to plug it in the first one. All right, so if you plug this in correctly, I got 6U for units. Okay. All right, so it says this. It says find the rectangular coordinates. Okay, so recall what our formula is for that, right? So remember, this is R and theta. Okay, so recall rectangular coordinates. So x equals r cosine theta, so in this case negative 2 cosine. Let's change theta to degrees, so that's 240. And y equals negative 2 sine theta, so 240 there. And so negative 2 cosine 240, that gives me a 1. Sorry, I forgot to see I can scroll up here too. I'm sorry about that. Okay, and then negative 2 sine 240 gives me root 3, and so that's your order pair right there. It is 1 comma root 3. Okay. All right, 3 comma negative 210, again, same thing. R theta, x equals r cosine theta, so in this case 3 cosine negative 210, and y equals 3 sine negative 210. Go ahead, plug those into the calculator. 3 cosine, make sure you write in the negative for the 210. You get a negative 3 over 2, and then you do 3 sine negative 210, and you get a positive 3 over root 2. Make sure you know the difference, guys. That's just a rectangular coordinate. We're not doing our complex yet, like we've been working on this week. Okay, now it wants us to find 2 pairs of polar coordinates for each of the given rectangular coordinates. So now we're just going to polar. So recall how we do that. Remember, r is equal to the square root of the rectangular coordinates squared. So parts of the rectangular coordinates. So 2 squared plus a negative 2 squared. So that gives me square root of 8, because that's 4 plus 4, which then equals 2 root 2. And then theta, remember, it's just tan inverse of y over x. Now, when I look at this coordinate is in quadrant 4 because positive x, negative y. So I'm going to go ahead and I'm going to add 360 to it, because I'm trying to get to quadrant 4. If you're trying to get to quadrant 2 or 3, you're going to add 180. Okay, so we're going to tan inverse here of negative 2 over 2, and I'm going to add 360 to it, and I get 315. So my first point right here is just going to be 2 root 2, comma 315. Now this is a lot like up on number 1 with multiple representations. So I think the easy thing to do is just keep the r the same, because we know we're going to have another point with a positive r, and so that means then that this angle and this angle we're about to find here are coterminal. So I'm just going to take that 315. I obviously can't add 360 to it because it has to be between negative 360 and positive 360. So I'm just going to subtract 360 and get negative 45 degrees, and there you go. Okay, let's go ahead. Let's look at B here. So again, r equals the square root negative 4 squared plus a negative 7 squared. Now I'm trying to think that off the top of my head. That's going to be 49 plus 16. Okay, so square root of 65. Does that break down at all? No, it doesn't. So it's just the square root of 65. And now let's go ahead and let's find theta. So tan inverse negative 7 over negative 4. Now look what quadrant you're in here based on this point. That's quadrant 3, negative, negative. So we're going to add 180 here. And let's see what that gives me. So tan inverse here, negative 7 over negative 4, close parentheses, plus 180. And let's round to the 10th. So I got 240.3 degrees. So that's going to be my first point here. Okay. And so again, I think it's just easy to keep r the same and just know that they're coterminal, right? And so because we understand it's a lot easier, so we're just going to take that 240. Again, I can't add 360 because it's greater than 360. So I'm going to do 240.3, subtract 360, and I get a negative 119.7 degrees. And there you go. Okay? Guys, we did not do 5. I'm sorry, I forgot to remove that. We did not cover that, so cross that out. We also did not do number 6. So go ahead and cross that out as well. That will not be on the test, obviously. Okay, so let's look at 7 here now. So it says 7, it wants me to graph. So recall, this point is negative 4, negative 1. You're just dropping the I there. So I'm going to go left 4, down negative 1, and there you go, graph it. Then it wants us to convert it to polar form. Okay, so again, how do we do that? Well, here we go. We're going to find r. So r is equal to the square root of both the x and y values of the rectangular coordinate. And so that's going to give me square root of 17, because that's 16 plus 1. And then now we need to find theta. So theta is equal to tan inverse the y value over the x, so negative 1 over negative 4. Again, this is in quadrant 3, so I'm going to go ahead and I'm going to add 180 to it. And so now we do tan inverse in our calculators. Negative 1 over negative 4 plus 180 will give me 194. So now let's go ahead and let's remember our formula. So our formula for our complex number in polar form is this. It is r, so root 17, comma cosine of theta, what we found for theta, so 194, plus I sine 194, and there you go. That is your complex number in polar form. Okay? So now we're going to do the opposite. We're going to go from polar to rectangular. And so recall, before you can go to rectangular, you need to know what your polar coordinate is. So my polar coordinate, how did I find that? I just find that looking at my formula, right? Well, we know that has to be r, we know that has to be theta. So we know it's going to be 345. I changed the pi over 4 to degrees. Let's go ahead. It wants me to graph that. So my 45 spoke, 30, 45. So from the origin on that spoke, you're going to go up 1, 2, 3 because r is positive. And there you go. There's 345. So now we want to go ahead and we want to find the rectangular complex form. And so we do that by saying this. A is equal to r cosine theta. B is equal to r sine theta. We kind of went over this on the front as well. This time now we're dealing with complex numbers though, so it's a and b, not x and y. Know the difference. So a equals 3 cosine 45 degrees, b equals 3 sine 45 degrees. And so that's going to give me this. Let's go ahead and type it in, 3 cosine 45. That gives me 3 root 2 over 2. And then 3 sine 45 is going to give me the same. But remember this time, because we want complex, do not forget about the I. Okay, do not forget about the I. All right, number 9, it wants us to go ahead here and multiply. Okay, so write the answer in polar and rectangular forms. Okay, so first off, let's go ahead and multiply here. So when we multiply the r's on the outside. So real quick, here's r1, r2, theta 1, and theta 2. Okay, and so recall when we do the formula, okay, we go ahead here and we multiply the two r's on the outside. So we're going to have 2 times 3 bracket cosine 240 plus 60 plus I sine 240 plus 60. And so for my polar form, then it's going to be this. It's just going to be 6 cosine 240 plus 60 is 300 degrees plus I sine 300 degrees. Okay? For rectangular, we just did it on this last problem here. A equals 6 cosine 300 degrees, B equals 6 sine 300 degrees for rectangular. So let's go ahead and plug that in. 6 cosine 300. Enter, that gives me a 3. 6 sine 300. That gives me negative 3 root 3. And do not forget the I on the end, because we're looking at complex numbers. All right, this time we're doing a division. So that looks like this. So when you do division, you take your R1, your R2, you take your theta 1, your theta 2, and you're going to go ahead and you're going to subtract. So, you're going to divide the R. So it's going to be 6 over 2, bracket, cosine, theta 1 minus theta 2. So we need to go ahead and change those into degrees. So that's going to be 135 for theta 1. Theta 2 is going to be 45. So 135 minus 45 plus I sine 135 minus 45 bracket. And so my polar form then is going to be this. It's just going to be 3 cosine 135 minus 45 is going to be cosine of 90 degrees plus I sine 90 degrees. And there we go. Okay. Our last problem here, 11, is using de Moivre's theorem here. Okay. So once the polar form, so recall how we do that. Remember, based on the 5 here, that's how we set it up. Sorry, let me scroll up. I apologize. So based on the 5. Okay, so we're going to do this. So remember, we raise the r to whatever the power is, so 2 to the 5th, bracket, cosine. You take the angles now and you multiply them by whatever the r is, whatever the n, the power is as well. Okay, and now let's go ahead and let's simplify. So 2 to the 5th power, that's 32. So really, here's our answer, sorry, because it just wants it in polar. We don't even have to do rectangular, okay? So you're just going to get 32, parentheses, cosine 45 times 5 is 225, plus I sine 225. Parentheses. All right, that's it. Thanks, guys. Have a good day.